Hello children. We were doing applications of derivatives. Under that we were into rate measure. In rate measure we have done around 14 problems. Now I'm into the 15th problem and I hope you have not forgotten how to write the data. We'll get into the data of this next question, that is question number 15. Question number 15 tells you that a particle moves along the curve 6y is equal to x cube plus 2. This is the curve given to us. Find the points. So I need to find out the points on the curve at which the y coordinate is changing 8 times. Y coordinate is changing dy by dt. How many times is equal to 8 times 8 into as fast as the x coordinate is changing. So it is dx by dt. So they have given the data like this. Given 6y is equal to x cube plus 2. Find the points. Points equal to question mark. And they have given that y coordinate is changing. dy by dt is equal to 8 into dx by dt. This is what they have given. Y coordinate is changing 8 times as that of the x coordinate. Now to substitute for dy by dt, I need to differentiate here with respect to time. So 6 into dy by dt is equal to 3x square. For 2 it is 0. Now dy by dt I'll replace by whatever they have given. Oh, 3x square into dx by dt I've got. Okay. Sorry. 6 into dy by dt I'll write as 8 into dx by dt is equal to 3x square into dx by dt. dx by dt is gone. And x square is equal to 6 into 8 divided by 3. 3 ones are 3 twos are, which is equal to 16. 8 twos are 16. So x is equal to square root of 16, which is equal to plus or minus 4. Now underneath this you take two cases. Okay, underneath this you split your pages like this, and once you do x equal to plus 4, the other time in the second case you take x is equal to minus 4. Where are these points? These points are on the curve. So my curve equation is whatever they have given. So I'll go here, these points are lying here, which means that this x equal to 4 can be plugged into our curve equation. That is equation number 1. So when x is equal to 4, equation number 1 implies 6y is equal to 4 cube. Okay, let me write 4 cube plus 2. So y is equal to 4 cube is 64, 64 plus 2 is 66 by 6, which is equal to 11. Therefore, point 1 is equal to x is 4 and y is 11. I got point number 1. Now like this we'll do for point number 2, wherein I'm taking x is equal to minus 4. So I'll go back to equation number 1, that's the curve, and I'll say 6y is equal to minus 4 whole cube plus 2, and that will give you y is equal to this minus 64 plus 2 is minus 62. Minus 62 divided by 2 gives you, sorry, divided by 6 gives you minus 31 by 3. 2 3s are 2 1s are. Therefore, I got my point number 2, which is equal to, when x is minus 4, y is minus 31 by 3. That's point number 2. Okay, now I've got the 2 points which are lying on the curve. Now, other than this, in this I would like to tell you that this is about a curve moving, and this is an important question for PU board examination especially. Uh, they're asking for the points. Now basically this, like this, we are going to do in tangent and normal also. This is the application of derivative C, where all it is applied. We apply it for cube, we apply it for rectangle, we apply it for the movement of the ladder, we apply it for the movement of a vehicle, we talk about speed, we talk about not speed, we talk about velocity, acceleration, and now this is about a curve, how it is moving also, and we can find out the points on that also. See how all the differential calculus is applied into different fields. And I have given an example priorly like how it is used in even in biology, wherein and in chemistry we talk about rate of reaction, and physics just now I gave you plenty of examples where we talk about velocity, acceleration, and when it comes to mathematics itself, we can find out the movement of the uh, menna curve or the movement of the ladder, etc. Okay, going. That's the beauty of maths. Without maths, there is no life at all. Every day, day in and day out, we'll be using maths in our life. And by doing plenty of math, your mind will get tuned to kind of situations wherein you have to find out solution for every problem in life. That's what is mathematics. What is mathematics? We have a problem, we'll find solution. When you start tackling different things without your own knowledge, you will be you will in life, that's how it is applied. That's how is the application for life. You will get tuned whenever you get stuck in some situation, you will start thinking about the solution for that. Okay, let's get back to mathematics. We have question number 16, wherein sand is pouring from a pipe. Sand is pouring from a pipe at the rate of 12 centimeter per second. When sand is pouring from a pipe, you can see this lorry is unloading this sand. Is it not? It will be pouring. What kind of shape will come out? The shape will be a cone. And when the cone is coming out, when the sand is pouring, it forms a heap like this, and as the sand pours and pours, it increases. The cone height will increase, as well as the base radius also will increase. See, radius will keep changing, and the height also keeps changing like this. So which means I mean to say whatever is variable, that is always differentiable. So now I can differentiate radius also, I can differentiate the height also in the cone. But when I'm doing the problem, I can differentiate exactly with respect to one variable. That is why in all these kind of problems, they'll give the relationship between the two variables. How is radius related with height? Any kind of variable like this which is related to one another uh, in the situation, they will give the relationship between the two, so that you can convert the two variables to one variable, and then only I can differentiate. So let us see what happens in this problem. Sand is pouring from a pipe at the rate of, so what is going to increase? Volume will increase, volume of the sand. So they have given dv by dt is equal to 12 centimeter cube per second. The falling sand forms a cone on the ground. How? In such a way that, how? In such a way that height of the cone h is equal to always one sixth of what? One-sixth of the radius of the base. One-sixth of the radius of the base. Let us write the next. We'll continue with the data, and let us write what is it I have to find out. Continuing, how fast is the height of the sand cone increasing? So dh by dt, how the height is changing with respect to time. When the height is 4 centimeter, when the height is 4 centimeter, when h is equal to 4. Now, if they have given the value for h for the height as h is equal to 4, I have to find out, which means that h should be there even after differentiation. So what should I get rid of? I should get rid of R inside my formula. So let me come to, see, volume numerical value is given. So I'll start with volume of the cone formula. Volume of the cone is 1 by 3 pi r square h. Okay, so now here see, R also is a variable, H also is a variable. I can differentiate only with respect to R, or I should differentiate only with respect to H. But since in the data they have given, I am supposed to plug H as equal to 4, they have given so I have to have only H here. I should not have R. So I'll write what is R equal to. What is R equal to from the given data? R is equal to 6H. So I am going to plug the R is equal to 6H here, and we got volume to be pi by 3 into R square is I'll write 36H square into H. 3 ones are 3 12s are. So we got the formula to be V is equal to 12 pi H cube. So according to the given condition, my volume got reduced to 12 pi into h cube. Now we'll differentiate this with respect to t. dv by dt is equal to 12 pi into 3h square dh by dt. Now dv by dt is given to be 12, and the remaining I'm going to transpose this side, divided by 12 pi into 3h square is equal to dh by dt. 12 got cancelled. So dh by dt at h is equal to 4 is equal to 1 by 3 pi. Okay, I'm doing at now. I'm going to plug for h whatever they have given. They have given h should be equal to 4. So 1 by 3 pi is constant, and h square I'm going to write as 16, that is 4 square, and 16 3s is 48. So I got 1 by 48 pi. I'm sorry, 1 by 48 pi what? 1 by 48 pi, we are talking about height. So what is the unit that I'm going to write? It is going to be centimeter per second. So dh by, so therefore height of the cone. And for all the statement problems, at the end of the problem you are going to declare your statement according to what they have questioned. See, they are asking how fast is the, so we will write therefore height of the sand, therefore height of the sand is increasing at the rate of 1 by 48 pi centimeter per second when the height is 4 centimeter. Now this is a declaration of the answer at the last. You have to do it in your exam paper. The presentation will be complete. Okay, and now I hope this is clear. Only in this problem we have two variables, and one variable should be expressed in terms of the other according to what they have given. Here they had given h, and so I replaced r as 6h. Suppose they had given r equal to 2 or something, then you would have written h as, you have plugged in h as r by 6, and so on. Okay, we go to the next one, that is question number 17. It tells about total cost. And we saw that, see, this is an application of mathematics in commerce field, children. See, when I have to find out the average cost or the average revenue, then we have to differentiate it. If they have given the average revenue, if I have to find out the total cost, then I do the reverse process of differentiation, that is integration. So here you have the total cost C of x in rupees is given to be something. So I'll call this as T of C. TC equal to, that is 0.007 x cube minus 0.003 x square plus 15x plus 4000. Okay, this is the definition given by total cost. And you know, this is called as the variable cost. We have something called as fixed cost and variable cost in commerce field. Suppose in you I take a pencil and it has, for that to be manufactured, maybe I take only 3 rupees. But then I'll be charging, when I give it to my seller, I'll sell it for 4 rupees. He will sell it to somebody else and he'll sell it for 5 rupees. So each one has to get it their profit, is it not? So that is called as the variable cost. The basic manufacturing cost was only 3 rupees. So when I'm in utter loss and I want to give away all the stock, so what I do, I'll sell it for 3 rupees so that I will be under no profit and no loss situation. So this is called as, wherever you have all this X thing, this much is called as the fixed cost, the manufacturing cost, and this is called as the variable cost. It depends on the first person is selling or the second person is selling, or is it from state to state, or is it from country to country, or is it from state it has come to, from central it has come to state, and from the state it has gone to, so on different products we'll have definitions like this. So this is how mathematics is used in market area also. So we'll come to this. So this total cost definition is given to us, where x will be the number of units, number of items, number of pencils, number of books, whatever it is, number of scooters, number of cars, whatever it may be. The marginal cost I have to find out. Marginal cost is nothing but differentiation of total cost. So I'm going to differentiate this like this: 0.007 into 3x square minus 0.003 into 2x plus 15. I differentiated. And now I need to find out marginal cost at something whatever they've asked. What is the marginal cost when 17 units are produced? When x is equal to 17. X denotes the number of units. So now I'll plug in x is equal to 17 and shall find out. I shall use calci for this. You have 0.007 into 3 into x equal to 17 square is 289 minus 0.003. 17 twos are 34 plus 15. So now I shall do this calculation as point 007 into 3 into 289 is equal to 6.069, and then plus 15 minus, okay, let me do this, 0.00. No, I shall do like this: 3 fours are 12, 1 carry 3 threes are 9 plus 1 10. I should put the decimal point after 3 digits. So it is 0.102 is equal to 6.069 plus 15 minus 0.102 is equal to, it is 20.967. Now this is the marginal cost that is given to us, that is will be in the market when the total cost is so much. So this is the marginal cost, that too when exactly 17 units are produced. Now like this, whatever the number of units are produced, this marginal cost, like on an average, what is the single unit mm, rate, I can find out like this. Okay, like this exactly we can do for revenue also. So we have here, we have total revenue in rupees received from the sale of X units of a product. E is given by, so they have given total revenue. I'll call it as TR. TR is equal to 13x square plus 26x plus 15. Now I need to find out marginal revenue. Marginal revenue is d by dx of total revenue. So I'm going to differentiate it. 13 twos are 26x plus 26. This is marginal revenue. But then they're asking us to find out the marginal revenue when number of units is equal to 7. So MR when x is equal to 7 is equal to 26 into 7 plus 26. That is equal to 26 into 8. Am I right? I have taken out 26 common. Then you will get 7 plus 1, 8. So 26 into 8. 8 6 are 48. 8 2s are 16 plus 4, 20. So this is marginal revenue is this much. 208. It will be 208. Okay. And we have one more like this with revenue only, and it is an objective. So TR once again, total revenue once again is X units of a product is given by TR is equal to 3x square plus 36x plus 5. And I want the marginal revenue for this. So we say marginal revenue is equal to d by dx of total revenue, which is equal to 6x plus 36. But they want the marginal revenue when x is equal to 15. So marginal revenue when x is equal to 15 is 6 into 15 plus 36 is equal to, so we'll do 15 into 6 is equal to 90 plus 36, which is equal to 126. This is the marginal revenue. 126 do you have? Yes, so D option will be the answer. And now children, this is the way we are going to use differential calculus usage, especially this rate measure. I appreciate it very much. So it is useful in various fields, which is very useful in getting the information, crucial information about doing things. I told you, in stocks and shares, in census, and in machinery, and then in reactions. So many ways it's useful. All right. Now this is about in application of differential calculus. There are in one unit we have 5 chapters, and we are done with the rate measure. And after this, we'll get into increasing and decreasing functions. Okay, we have something called as increasing and decreasing function. I need to find out when is the curve increasing. What do you mean by increasing? It has to go rise up, is it not? Decreasing means what? It has to come down. So I want you to understand this increasing and decreasing function in a very simple way, where you can visualize the graph looking at the equations. No, you should be able to know, like, when I say sine x, you should understand that it is a curve. It's a sinusoidal curve which will keep moving like this, up and down, like a wave. Sine wave, cos wave, we say. So sine wave, cos wave has, it is neither increasing nor decreasing when I am talking about, say, some 0 to 360 degrees. 0 to 360 degrees, the curve will go up, it will come down, again it will go on, it will come down, and it will stop there. So from 0 to 360 degrees, when I consider the curve, sine curve, it is neither increasing nor decreasing. It was in the same level. So now I'll come to sinusoidal wave. This I'll say increasing and decreasing functions. All right. So now I'll take a very simple example. So this is 90, 180, this is 270, 360. So I'll write 90, 180, 360, 270. I'll start drawing the curve. And I know that all my sine values will be lying only between +1 and -1. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 360. Oh, I made a mistake here. 180, what did I write? 180, 270 and 360. Sine 270 is -1, sine 360 is 0. So when I take like this, see how the curve is? It has come down to the same level. Though it has gone to the top, it has come here, then it has come down here, it has come to the same level from here to here. And then when I say from 0 to 180 also, it's neither increasing nor decreasing. Is it so? Is it so? And then like come back here again, see, it has come back to the same point. See, it is neither increasing nor decreasing. When I see the level is there only. So what do you mean by increasing and decreasing? When you feel that the curve has taken an initial point, it has started here and it has gone to the top, then I say it is increasing function. It has gone from level 0 to level 15. Okay, it is increasing function. Or if it was in level 15 and then it has come down somehow like this, it has flown down, then we say it is decreasing function. If it has come to a lower level, that's what we say decreasing point. Okay, so but whereas when I'm coming to sinusoid or this cosine wave, it will be lying in the same position. See, it started from here, it went, it came down, again it came to the same place. So we said between 0 and 360 degree it is not increasing, it is neither increasing nor decreasing. So where is it increasing? But if I change the interval, look, 0 to 90 degree, I will give you, how is your curve? See, it is like this, it is like this. So it was here 90 degree, it is here. So in this part it is increasing in 0 to pi by 2. The sine value, the sine wave has increased from 0 to pi by 2. What about this from pi by 2 to pi? How is it? See, from pi by 2 to pi it has come down like this. So this is decreasing. See, this part, it is decreasing in pi by 2 to pi by 2 to pi, closed interval. Now I'll also write the values. See, for example, in between 0 and pi by 2, the values of sine will be sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. I reached there. Okay, then I'll continue. Oh, sine 90 is 1 here. It was 1. After 90, next I'll go to 180, it will come to 0. See, from 1 to 0, it will decrease. Again, it will decrease. Why is it so? 90, I mean, like, I'll come down. After 90, let me take 90 plus 45. 135. 180 minus 45. It is 45. So, it will be 1 by root 2. 1 by root 2 will come here. I'll take plus 30. 90 plus 30 is 120. What is 120? 120 is 180 minus 60. So you would have got root 3 by 2 here first. If I say 90 plus 30 so much, 90 plus 45 so much, 90 plus 60 is 150. That you will get 1 by 2. So it will slowly reduce to 0. It has decreased. Okay. So between 0 and 180, it has gone to, if I say 0 to pi. Whereas, so I'll write, whereas sine x is neither increasing nor decreasing in the interval 0 comma pi. Why? Let me take 0. See, I'll take like this closed interval. It is neither increasing nor decreasing. It went up and again it has come back to the same place. So it's neither increasing. But when I change the interval, if I say 0 to pi by 2, it is increasing. When I say pi by 2 pi, it is decreasing. So it depends upon the intervals how the curve is. Now this is called as increasing and decreasing when it comes to the graphical way of understanding. Now what do you do when theoretically, what is that? What is the meaning of this? See, whenever I draw a curve, see, I draw a curve x, y, and I have a line like this. A curve has gone up. And any point I have to find out whether it is increasing or not. I will draw a tangent to that. And this tangent will make a certain angle with x-axis. And I have to find out the slope of this tangent. Don't you see that this tangent is lying, when I extend this tangent is lying in first quadrant and third quadrant. Now from the previous year's analytical geometry, we have learned that whenever a straight line is lying in the first quadrant and third quadrant, then it will have a positive slope. Slope will be positive because it is making an angle. What angle? The acute angle with x-axis. What is slope equal to? M is equal to tangent theta. M is equal to tan theta. If theta is acute, and I know that tan is positive in the first quadrant and also the third quadrant. So see, whenever the line is between first quadrant and third quadrant, I know tan theta, whatever the angle it makes, will always give a acute angle. If this is acute angle, it will always give you a positive value. Okay. Next I will continue. I'll continue like this, and then I'll continue like this. Then you see that the slope value will start increasing. Here when I take tangent here, it will be some say 1. Here it may be 2. Here it may be, in this position it may be 3. So slowly tangent value is increasing. So whenever the tangent value, that is m value, is increasing, then we say that the curve is having, for every different point it is increasing and increasing and increasing. So it is a strictly increasing function. For every point it is increasing. Now there are certain functions. So this we say it is strictly increasing function. It is strictly increasing function. Okay, now suppose you have a curve like this. See, somewhere it will come down here where the tangent, if you draw, it is going to be, tangent will be parallel to x-axis, and the tangent becomes 0 there. At particular point, m is equal to 0. What do you mean by m? Slope of the tangent. Slope of the tangent is what? For if the tangent is parallel to x-axis, and so the tangent's slope and the x-axis slope will be equal, so it will become equal to 0. So wherever we say slope is 0, then I know that the wave has increased. So look at the wave, it has increased to a certain level, and there it will come down to one particular point where it is straight, and then again it will increase. When you look at the initial point, initial position and the final position, it has increased totally. Okay. On the whole, looking at the initial point and the terminal point, it has gone to a higher level. So I'll say it is increasing function, but it is not strictly increasing. In between, it has not, it is not increasing for every point. For some point, here slope is 2, here also 2, here also 2, something like this. Okay, or it may be equal to 0. And wherever it is equal to 0, it would have become, the slope would have become, where when you draw the tangent will be parallel to x-axis. So what do you mean by tangent parallel to x-axis? What will happen to the curve? The curve would have come to a still. It is neither increasing nor decreasing there, and from there on, somewhere in some particular point, it will start increasing again. So in this particular part, it is increasing again. From here to here, it is increasing. In between, it has been parallel to x-axis. The slope, the curve has been stationary. We say the curve is stationary. So we get certain stationary points where the curve has stopped. Okay, and after that particular stationary point, it may increase or it may decrease also. So if it is decreasing, the direction will change, it will come down. It may, if it is decreasing, or if it is further increasing, then totally, on the whole, the function is an increasing function, but not strictly increasing. This will be a strictly increasing function. So how do you show figure in the figure? And later on, how are you going to do theoretically? What are you going to do with this? So see, if I say this is strictly increasing function, from it is gone from top to bottom, for every point it is increasing, so this is strictly increasing. Okay, this is only increasing function, because when I compare from this point and this point, it has given a rise, and that's why it is an increasing function, but it is not strictly. Similarly, when you come to decreasing function, this is a decreasing function, whereas, so this is a strictly decreasing function, strictly decreasing. And when you have like this, it is not, it has only decreased. From there, it has come down and it has come to this point. So this is only decreasing function. Okay, this is where these are called as increasing and decreasing functions. How are you going to do theoretically? What is that we have? For every interval in between, if it is supposed to be 0, what is that geometrically we do? We differentiate it. Y is equal to f of x. A curve is given. I will differentiate it this. Why do I differentiate? When we come to tangent and normal, I will tell you what is the meaning of differentiating a curve and how do you get a tangent. See, whenever you differentiate and plug the point, I would have given a certain point, some interval. When you plug the point dy by dx at the point, you always get slope of a tangent. Slope of a tangent. So what is the procedure that I should follow for increasing and decreasing? For y is equal to f of x curve, you differentiate this. And this slope of the tangent is always, if it is always positive, then we say it has been increasing, it's going up. And if it is negative, and I also will show you whenever for a decreasing function, if you draw a tangent anywhere, the slowly the tangent will start, you can see that it will always give you an obtuse angle. See, it will always give you an obtuse angle with x-axis. So theta is obtuse here, theta are all obtuse, and you can see the tangent is lying in second quadrant. When you extend this, it is lying in second quadrant and fourth quadrant, where tangent tan theta is negative. So if dy by dx, when you differentiate, you get slope of the tangent. So if that dy by dx, that is slope of the tangent, is negative, then I know that the curve is slowly coming down. For every point, if it is decreasing slowly coming to a lower level, then I know that it is decreasing function. So geometrically, you please understand that whenever you do dy by dx, you get what? Slope of the tangent. And if this slope of the tangent is positive, it is increasing function, and if it is negative, it's going to be decreasing function. So what is that I want you to understand? Slope of a tangent. So let me write important point for you to remember. The only important point that you have to remember, let me erase and write. I don't want you to see this. I want this, whatever I write now, it should stay in your mind. So totally increasing and decreasing function, what is that I'm going to follow? Dy by dx greater than 0. Dy by dx greater than 0, that is, it's positive. This implies that f of x is an increasing function. And of course it always depends on the interval what they have given. Increasing function. Secondly, if dy by dx is less than 0, that is if it is negative, you will do dy by dx and plug the point. Okay, dy by dx and plug the point there, or dy by dx you plug the point and becomes negative there, then in that particular interval you can say f of x is a decreasing function. It is a decreasing function in that particular interval. So what is that point that you are taking here? Whatever the interval I have given, you take any point and plug there. Because if you have a curve like this, you draw tangent here, it is positive, you draw tangent here, it is positive, you draw tangent here, it is positive, here you put it is a it's a positive, it's always positive. So slowly, okay, this should not turn like this, it should be like this. Okay, if it is turning, so you keep drawing tangent every time it is positive. So dy by dx is greater than 0 and nowhere it is becoming equal to 0, then we say the curve is going up and up and up and up, means for every point. So this is an increasing function. And if it is decreasing, then we say it is a the differentiation will always be at any particular point in that per interval, it will always be negative. So what do you conclude for your dy by dx equal to 0? Dy by dx equal to 0, I will write gives the stationary points where all the wave is standing, gives stationary points. Stationary, you have NERY and NERY. Be particular with the spellings. This is stationary NERY, stationary points. So, these stationary points are the points where my curve is increasing and where the curve is decreasing. So, in the sine curve itself, if I take like this, okay, these are all the stationary points and we call that as critical point also. Stationary point is a point where the curve comes to a stand. It'll come to a still there, it'll stand on there, the wave is standing. But then I'll call it as a critical point because when I call it as a critical point if it changes its direction. Okay, critically, that's, we say critical position in life. So what do you mean by critical position? There is a turning point in my life, something there is a changeover. So here also, if there is a point from where on the curve changes its direction, we call that as a critical point. So whether to find out stationary point or you have to find out critical point, your job is to do differentiation, equate it to 0, then you will get stationary points x is equal to, maybe you will get 1 point, 2 points, 3 points, and whatever, it may be only 1 point also, 2 points, 3 points, any number of points where the curve is coming to a stand. And without making equal to 0, without having any point equal to 0, for every point, if it is increasing, if it is positive, then I say it is an increasing function. If dy by dx, now this is the point what I want you to understand for your objectives in JEE. So if they give you a curve or some curve equation and ask you to find out whether it is increasing or decreasing, giving you an interval, you have to differentiate it because I have to find out the slope of the tangent. Okay, so differentiate it, and in that differentiation you plug the point of the interval whatever they have given. They may give you 2 comma 4, then you put the in between some number, say 3, put 3 in the differentiation. If you get positive, you will declare it as an increasing function. If you get negative, you will declare it as decreasing function. And if it is equal to 0 exactly, then you will say it is neither increasing nor decreasing. So a simple point that you have to understand is, given y is equal to f of x, if they have given y is equal to f of x, you will do dy by dx and start plugging the interval point. If it is positive, it is increasing. If it is negative, it is decreasing. If it is exactly equal to 0, you are going to get the stationary points. All right. With this, I'll come to the end of this uh, session. And in the next session, I will tell you the definition of the increasing and the decreasing function. What is the interval? How are we going to do? So how is that? Theoretically, you write the definition, and we'll get to see the graphs of some increasing, decreasing, as is given in your textbook. And then we'll run on into the algebraic equations for problems where I have to find out whether the given function is increasing, decreasing, or does it have a stationary point, or is it that it does not have any stationary point, is it strictly increasing, is it strictly decreasing, we'll find out. Okay, so catch you on the next session. Thank you, children.